Hello, Mr. Nemo here. We're back for video number 3 of our quiz for Friday. I think it's the 12th. This one is talking about something that we did a lot in our homework, which is which triangles are similar. So the first thing that I would start is to find the ratio of length to the width. So in this one we have, if we start up here, we got to go 1, 2, 3. So this side length is 3, and it's by a, starting here, 1, 2, 3, 4, a 3 by 4. Make sure you count your sides correctly. This one is starting here, 1, 2, 3, 4, 5, 6, and going down, starting here, 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to put this one on the inside. That's a 6 by 8, and this one starting here is a 1, 2, 3. Doesn't quite make it all the way, but we're going to pretend. And we're going to start here. We'll go down 1, 2, 3, 4, 5, 6. So once you find your side lengths, you find the ratio of the length to the width. So in order to do that, for number, I'll just label these 1, 2, and 3. Number 1, I would just put the 3 over 4. And 3 over 4 is equal to 3 over 4. That cannot be reduced down anymore. Rectangle number 2, I'm going to work on the inside, would be 6 over 8. Well, those are both even numbers and they're big. I think we can reduce that down. We'll divide by 2, and we get 6 divided by 2 is 3, and 8 divided by 2 is 4. All right, something right there just clicked. And then for number 3, we have a 3 over 6, and again, we can divide that. Let's divide that by 3, so we can divide this by 3, and we get 1/2. Now, taking a quick look at those, something should jump out at you that it doesn't match up. And I think it's all the way down there on the right side, but I don't want to point them out yet. I don't want them to feel bad. Next thing we're going to do is the scale factor. And the scale factor, let's do from we just worked on triangles. Now we're on rectangles. From rectangle 1 to rectangle 2. So we're going to take the biggest side of rectangle 1 and to the biggest side of rectangle 2. And I'm going to say that the scale factor, new over old, doesn't really matter what we do here. We'll just put 4 over 8, which is 1/2. Now we'll find the scale factor from rectangle 2 to rectangle 3. So scale factor is going to be, the big side is 8 on this one, so we'll use the 6 on this one. So 6 over 8, 6 goes in, well, we got to use 2 here. 2 goes in that 3 times, and 4. So it's a little different. So once again, we're getting something different from rectangle over 3 over there. So I think it's safe to say that I'm leaning towards 1 and 2 being our similar rectangles. Let's check on the angle measure. Well, I think it's given that every single one of these is a 90 degree, right? And so they're all right angles, so that checks out. Let me see what else we can check. Perimeter. Oh, yes. So if we have, back to number 1, we have a 3, 3, 4, and 4. So that would be 8 plus 6 is 14. Then this one we have 8 and 8. 8, 8, 6, and a 6. These are just the side lengths. I'm going to add them up. 8 and 8 is 16 plus 6, 20. So I think that is 28. All right. And then this one we got 6, 6. And again, you can rewind this. Go and check what I'm doing. Whoops, I didn't need a comma there. 6, 6, 12 plus 6 more, 18. So if I take the scale factors of, let me see, the 1/2 isn't 14. 1/2 of this 28. And if we look at the scale factor here, the 3/4, I don't believe that the 18 is going to be the 3/4 of the 28. It just doesn't work out. So another thing you can check is the area. And so the area of the number 1 is 12, and then the area of hold on one second, let me figure these out real quick. So I found the area of our shapes of our rectangles, and lo and behold, the area of number 1 is 1/4 of 48. Now, what's so special out? Remember, 1/2 times the 1/2 is going to give us our 1/4, and there's our connection. So 1 is definitely similar to 2. Study, study, study.